25th question that reads a ball moving with a uniform velocity in a free space collides with another stationary identical ball, and thereafter each of them move at an angle 30 degree from initial direction of the motion of the first ball. Find fraction of the initial kinetic energy lost in the collision and also find the coefficient of restitution. So let's consider a mass of each ball is m, and the first ball has initial velocity u as shown in this figure. So this was moving in positive x direction. Let's consider, and this is the another object or ball which is at rest. This is the scenario just after, just before the collision. And then during the collision, they will be obliquely colliding like this. Why obliquely colliding? Because they are identical bodies, and they are getting final directions 30 degree from the horizontal or from the initial direction. That means there must be oblique collision, right? So let's say this is the just after scenario. The first ball is going to move at this black color arrow direction 30 degree, and the second ball is going to move with this black color arrow direction v2 at 30 degree. Now if we know, if this let's call this angle 30 as a theta. So this when they are getting collided, then you'll find this, since this angle is 30 degree and the second ball was at rest, if it is moving at any direction, so that direction is basically the line of impact direction. So from horizontal, this v2 is at 30 degree. So this is the v2, this is horizontal, that means this angle theta is going to be 30 degree. So this is going to be the line of impact. So what we can do, we can say along the line which is perpendicular to the line of impact, that velocity of first ball will not change. So this u is made two component, one in the direction of angle theta, that is along the line of impact, and another component along the line perpendicular to the line of impact. So this angle is theta, so that becomes u cos theta, that becomes u sin theta. So that will say this component is going to remain u sin theta of the first ball. However, the component which was along the line of impact is going to now change from u cos theta to v1. So that is v1. Now we can find out the total velocity of this one, which is going to be coming because of this v1 and then this u sin theta, because here you will find all the angles are going to be 30 degree. How we can say so? Let's talk about this. This black color arrow from horizontal is 30 degree, and this is along the line of impact, so that is from the horizontal to 30 degree, that is theta. So this 30, this 30. Now we know from the line of impact this is at perpendicular, so this was 60, so remaining is also going to be 30. Anyway, in totality, the total these velocity components v1 and u sin theta are perpendicular, so you can find out the resultant velocity as well. Now, since these two components have resultant along this black color arrow, so we can use this tan 30, the direction of resultant, making theta angle, that is 30 degree angle from this component. So there is a rule for ball 1. Tan 30 degree is equal to the v1, this component divided by this, that means u sin 30 degree. Now from here, tan 30 degree we know is 1 by root 3 and sin 30 is 1 by 2. So you'll find this is going to be v1 is equal to u divided by twice root 3. So v1 is the value, v1 has the value u divided by 2 root 3. You can check these calculations. I have jump a step. Anyway, further, let's go. Let's consider these two together. When we consider these two together, our systems, we can have a linear momentum conservation along the line of impact as well. So line of impact, initially momentum is going to be mu cos theta. Let's consider this downside as a positive. And then finally it will be mv1 and then mv2. That will say basically v1 plus v2 must be equal to u cos 30 degree. Theta is 30 basically. Cos 30 is root 3 by 2. So v1 plus v2 is u root 3 by 2. We got to know what v1 is. So we can substitute over here to get the v2. If we do so, we will find v2 is going to be u root 3 by 2 minus v1, which is u by 2 root 3. You can multiply this by root 3 upside downside, so it will become 3u by 2 root 3. That simplifies to u by root 3. So point is v2, that means velocity of second ball is going to come as a u by root 3. Now we got to know the velocity of second wall after the collision. First wall after the collision, we know the velocity of ball 1 before the collision. This velocity we have assumed basically u. Now we can find out the coefficient of restitution, because it's the ratio of velocity of separation divided by velocity of approach along the line of impact. So if you look along the line of impact, separation velocity is going to be v2 minus v1, v2 minus v1. So it's going to be v2 minus v1. And the velocity of approach along the line of impact is going to be u cos theta. So v2 minus v1 divided by u cos 30 degree. That's the coefficient of restitution. Now v2 we have calculated as u by root 3, v1 we have calculated as u by 2 root 3, and u downside is u cos 30 is root 3 by 2. You can simplify, this comes out to be u by 2 root 3, and then you will find u get cancelled out, and this 2 and this 2 will get cancelled out, so it's 1 by root 3 into root 3, that's basically 1 by 3. So coefficient of restitution turned out to be 1 by 3. So that's one answer about coefficient of restitution. There's another part, fraction of initial kinetic energy lost in the collision. So kinetic energy lost in the collision is going to be delta Ke. So we are first calculating the loss in the kinetic energy, delta Ke. That is going to be initial minus final, because there's a loss. So initially should be larger, finally should be smaller. So initial minus final. Now initial is going to be half mu square. In final case, we will write minus kinetic energy of this first, then kinetic energy of second. First will be half m v1 square plus u square sin square theta, and second will have half m v2 square. As simple as anything. Now we can put the value of v2, we can put the value of v1 over here and simplify this. So once we place the value, we can take this half m as a common. This is going to become u square, and everything inside is going to be like, this is going to be a square of 1, this. So u square divided by 4 into 3, 12. And this is going to be u square sin square 30, sin square 30 is 1 by 4, so u square by 4. And this minus will go inside, so that will become negative minus, and it's going to be like v2 square, v2 was this, square of this is going to be u square by 3. Now from here you can take u square outside and simplify, so this is going to be 1, this is going to be minus 1 by 12, minus 1 by 4, minus 1 by 3, then you simplify it, it comes out to be overall mu square by 6. You can check this calculation, simplify this. Now it says fractional of energy that lost to the initial. So fractional loss of kinetic energy is change in kinetic energy, that is loss in the kinetic energy divided by initial kinetic energy, which is mu square half, or you can say mu square by 2. So this is going to be like delta Ke, which is mu square by 6, and then the initial was mu square by 2. When you simplify, it turn out to be 1 by 3, because mu square will get cancelled out. 1 by 6 divided by 1 by 2 is basically 1 by 3. So coefficient of restitution we got to know, and the fractional loss of kinetic energy we got to know as 1 by 3. That's how it's done. Thank you.